In this episode, we will begin to build our character, and before we start our character, I want to introduce some basics about character rigging. So, character rigging, also known as skeletal animation, is a technique in computer animation in which a character is represented in two parts: a surface representation uh, used to draw the character, also called mesh or skin, and a hierarchy set of interconnected parts, also called as bone or rigging or skeleton. And you can think it like this. The skin is attached to skeleton, and the skeleton is the basic structure or a simple version of your complex character model. So you can animate your skeleton to drive the animation of your more complex character. So this rigging system can describe not only human or animal structure, but also mechanical structure like robot arm or some simple structure like door. The most important thing for us is to understand how to use rigging and its hierarchy structure to represent our character or any model tool you may need in the future. And in another word, how to build a hierarchy structure in Grasshopper. So, what is a hierarchy structure in rigging? Here I have prepared a simple example for a skeleton, and let's take arm as example. So, if we rotate our upper arm, we can see this change not only our upper arm but also our forearm and hand. So the same thing also happened when rotating our forearm, in which the rotation also affect our hand. So in this structure, we called our upper arm parents object, and our forearm is a children of it. And likewise, our forearm is parent of our hand, and also the hand is our children object for the forearm. So this is the hierarchy structure of arm. Once we understand the hierarchy structure, we can use it to describe a lot of structures, human body, animals, and a lot of mechanical structures. Although Rhino is not an ideal animation or simulation software, we can also create more active and complex structure model in Grasshopper. And how can we achieve this rigging system in Grasshopper? First, we can set our upper arm box, and we will set the size and the rotation control, and then we will use our upper arm to define the base plane for our forearm, because we need our forearm to follow the movement of upper arm, and then we will use this plane to build our forearm box, right? So we will set the size and the rotation control, and at last we will use our forearm to generate data, which will be used to build our hand box. And this is how we're gonna build our character model step by step. But first, let's build our arm. Okay, first let's set an origin point, and based on this origin point, we will create our body box, and I will list all ergonomic data here that we are gonna use. For the body, we will use upper body length 860, and chest depth 250, and hip breadth 400. And here we can set the range of number slider, and by right click and edit. In the panel, we can set our minimum and the maximum value, which is 711 for upper body, and name it upper body. uh, and 170 to 250 for chest depth, and name it chest depth, and then 300 to 400 for hip breadth, which is actually how wide the body is in our case, and name it hip breadth. And we'll use this as input data for our body box, which to create the box, we need a center box and set the input value and give it a try. And here's a small little settings here. When we build our center box, the distance is actually calculated from the center to the edge. So actually, what the width we need is actually half of the input. So we can set an expression here and set half of the value and get what exactly we want. And next, we are going to set a plan for our arm. We want it to locate at the center of the shoulder. So that would be the center of this line here. And here we will use several new batteries. First, we need deconstruct BREP, and this battery is a tool to get surface, edge, and vertical of a geometry, and we can get a panel to see the result. And let's see, these are all the surface, and these are all the edges, and these are all the verticals. So as we can see here, the deconstruct BREP can get a collection of elements of the input geometry. And to choose the line we want, which is this edge, we need another battery called list item. And uh, to, to explain this, I will need this panel again. So let's set the edges as input. As we can see here, the result is listed here, and each object has its own serial number. So what list item do is extract one object from the list. In order to choose the line we want, we need a number slider here and set input 12. So now we can see how the battery is selecting one of the edges. We don't know the serial number of the line we want, but with the slider, we can slide and choose the line we need. And next, we need to find the center of this line. Here we can use the divide curve we used before, divide curve, and set the division to 2. And then got our center point. And again, we can use list item to choose the center point from the collection. And again, a list item and select the center box, the center point. Okay, and next, to construct our plan, we need a battery called construct plan. And this one is good for our process here because we can define, you can see we can define the origin and the XY axis, so we can have a better control of our plan. And here we can use the center as origin and use the line we create before here as our y-axis, and we need one more line as our x-axis. So we can just copy paste another list item and slide to choose the line we need for our plane as x-axis and connect it. So here we got our plane. And one thing important here is that when we create our plan in our tutorial, we need to pay attention that we need to avoid default settings as much as we can. Every element that construct our plan should come from our geometry. We don't want universal axis to define our plan because universal axis won't follow our rotation. It will always face one direction, and that's what we don't want. We need our plan to follow the rotation of the parent object and always keep the rotation with our parent object, as I showed in our construct plan before. And in the next step, I'm going to set the rotation for our shoulder plan. And the shoulder joint is actually very flexible if you move your arm. And we can use two rotation here to describe it. So what we need is two rotation input here. And of course convert it to radians. Also we need two rotation battery, right? And the rotation 3D copy. And here we can set up our rotation. For the first rotation, geometry would be our plane, and connect center and connect input value. And now we need to define our rotation axis. Because as I mentioned before, we don't want any default universal axis setting. So I want the first rotation axis to be this direction, and we can get the rotate axis by deconstruct our plan here. So we need a deconstruct plan battery, and let's check it. We need the red axis here, right? So uh, this is our x-axis, and get it into the rotation axis. Okay, let's have a try. Yeah, this rotation is working now. And for the next rotation settings, it's almost the same. We need geometry, which is the rotated uh, plane here, and we need a center, and we need input value of rotation. Uh, and we need to be careful now because we cannot use the y-axis we have before, because when we rotate our plane here, the y-axis is also rotate. So the previous y-axis is no longer what we need. We need the new y-axis from this rotated plane, and so we need to deconstruct this plane again and take a look. The green axis is what we need, so we set it as our rotate axis. And now the rotation is set. We can check it. Rotation. Okay, everything is working. And next, let's build our box for upper arm, which we need another ergonomic data, that is arm breadth data and upper arm length. And let's set the range of this value. Okay, it's done, and we need a rectangle and a box battery for the box. Rectangle and box. And one more thing here we need to pay attention to is our rectangle battery actually work with domain. So domain is a range of number input, and if we directly set our input here, the rectangle is actually generate from 0 to 92, which makes the arm off the center. And what we can do is we can get a division and use division to get half of this value, and use create domain and set the half value as input. And for the start, we can actually right click and set the start as -46. So here we got a domain from -46 to 46. We can check it with panel. Let's get a panel and as set as input. And we can change the input values, and the domain will also change follow the input. So here we got our domain, and we can use it as our rectangle input. And now the rectangle is at the center. And then let's connect it to our box. And here we got our upper arm. Well, sometimes we have a problem with our plan is facing the wrong direction, and we can fix this problem with rotate our plan. And this is there's a battery called rotate plan. And for our case here, the rotation would be 180 degree. So we also need an input of 180, and also degree to radians, and set it as input. And try to rotate the plan. Okay, we can see now the arm, the joint is facing us, and sometimes this problem won't happen, but we can use this method to change the direction of the plan. So we can control the size of the upper arm, and we can control the rotation, right? So this work perfectly. And well, I think that's enough for this part. And in this episode, I mainly talk about how to use brief, brief deconstruct, and list item to generate one a specific element of our geometry, and we learned about how to construct plane with input of origin and the XY axis, and we learned how to construct rotation axis for our rotation, and uh, at last we use domain to create a center rectangle, and in the next part we will continue to construct our arm.